All right, so I just want to do example number 5 out of page 488. That's out of section 8.5. So it's the last type of question. Remember I said there were 3. So the first one was ones like in just the last video I did where they give you the equation of the line, the equation of the circle, and they say where does the line intersect the circle? It's usually 2 points. Then we did ones where it gives you the equation of the circle and it gives you a tangent point and it says what's the equation of that tangent line. Okay, so example 5 on page 488. Find the exact length from the point 7 and -6 to the circle x squared plus y squared equals 9. So again, let me draw you a picture so that you can see what it is they're asking. Do you always have to draw the picture? No, but it helps to understand what it is they're asking. So we have a circle that has a center of 0 and 0 and has a radius of 3. So it's not a very big circle. Now we have a point 7 and -6. That is not on the circle. That's way outside it somewhere. That's like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. That's like down here. And so they say find the length of a tangent from the point 7 and -6 to this circle. So if there was a tangent line on this circle that ended up here, so it might be coming across the circle. Remember, a tangent line only touches the circle in one spot. It might be coming from there, or it might be coming from this side. Only touches the circle in one spot, okay? So it could be on this side of the circle, or it could be on this side of the circle. It doesn't matter because it's the same length whether you draw it on that side or that side, it's the same length. So it doesn't matter. So let's say I drew it from that side down, but it doesn't matter. I could have drawn it from here. I will get the same answer, okay? I actually want to know the length from the tangent point to here. I want to know the length from the tangent point to here, okay? I know the center of the circle is 0 and 0, right? I know that. I also know that a line from the center of the circle to the tangent point, that's a radius, right? That's a radius. And I know that it's perpendicular. I know that. I know that the radius, if that's r squared, I know that the radius is 3. And if this line from the center to the point of tangency is a radius, that means the length of that line is actually 3. Now, I'm going to do a little bit of magic. If I draw a line from the center of the circle to this tangent point, what do I have now? I have a right angle triangle. Yes? Because length of a line, I know the length of a line formula is x2 minus x1 squared plus y2 minus y1 squared. And I know most of you know it because you used it on your test. But I need 2 points. I know the end of the line, and I'm trying to find the length of this line right here. Let's call it x. But I don't know what that point of tangency is. I don't know where that point is, and I have no way to figure it out. So, the fact that this is a right angle triangle actually helps me. I can't find the length of this line, but I can find the length of this one because I know it starts at 0 and 0. So let's call that an x1 and a y1. And I know that it ends here. So let's call that an x2 and a y2. So I can find the length of that line. I can do x2, which is 7, minus x1, which is 0, squared, plus y2, which is negative 6, minus y1, which is 0, squared. So that's 7 squared, which is 49, and that's 6 squared, which is 36. So this is the square root, 9 and 6 is 15. Okay, that's 85. No need to figure that out in decimals because you're just going to round it off anyway. And you don't even need to simplify the radical. Just leave it. This is root 85. Let me show you why. I still haven't found what I'm looking for. That's a U2 song. I still haven't found what I'm looking for. I'm actually looking for the length of this line. But if this is a right angle triangle, and I know this side, and I know this side, I can figure out the third side because a squared plus b squared equals c squared, and c is the hypotenuse. The root 85 is the hypotenuse because it's the one that's across from my right angle. So this is root 85 squared. One of these, doesn't matter, is 3. So let's say 3 squared. And I'm looking for a squared. We can call it x, we can call it a if we want. Doesn't really matter what we call it. So a squared plus 9 equals root 85 squared is just 85. So I'm going to move this over here. So a squared is 85 minus 9, which is what, 76. So a is the square root of 76. Now let me see what they said. Find the exact length. Exact length means I cannot give it as a decimal because that's not exact. I have to simplify the radical. Turns out 76 is 4 times 19. 4 has a perfect square root. It's 2. 19 does not. So the length of that line is 2 root 19. Let me recap. This side I know because it's a radius. So it's whatever the square root of that is. So it's 3. This side, which is the hypotenuse, I know because I can use my length of a line formula using the center of the circle and this outside point as my beginning and my end. Once I know this side and I know this side, I can use Pythagorean theorem to figure out the third side. All right? That's it. I'm going to give you just four questions to try, and then you can have your long weekend. So I will talk to you again on Monday when we are going to go back and review SOHCAHTOA. So if you like trig, yay. If you don't like trig, I'm sorry. It's my favorite thing. All right, so we will talk about trig on Monday.